Hello and welcome. Today I'll be going over the FlyingRC F4Wing Mini Mark 1. There you can see right there. This is the flight controller that I had showcased in my Flick build. It's a really small flight controller and it's not super mainstream. I like to use a Maytech flight controller or a SpeedyBee. The SpeedyBee ones have been pretty good. But this was something I wanted to try out, and I did receive some questions on it, so I figured I would order another one and answer some of those questions while sort of going over it here. So let's get started. This is how it comes. This is a spare that I actually ordered. I don't have any plans for this one other than just to have it on hand. I do have some drift frames laying around that haven't been flown in a long time. Maybe I'll throw one of this in one of those just to be able to fly a drift again would be nice. But anyway, let's get to it. Here I have the flight controller itself, and then this is the optional BEC that you can order alongside it. I have not tried the ESC that they have on their listing. It looks okay from what I've seen, but I can't speak to that. I also haven't tried this BEC here, but if it puts out 5 volts at a reasonable amperage, it should be okay for powering your servos. But anyway, let's open this guy up here. It does have some info on the target there, just some general specs about it. 7 PWM, 4 UARTs. I'll do some explaining over that. It does take 2 to 26 volts, so 1 to 6S, which is pretty nice. Yeah. I'll go over flashing the custom target for Inav on this thing here at the end of the video, so stay tuned for that. But let's get it out here. It comes in this little bag and in a little, actually nice plastic case. This is what comes in the bag here. This is just a tiny Phillips screwdriver. I really like this screwdriver. I found myself using the one that came on the original one in my Flick build quite a bit. Not really the focus, but it is nice that they include that. This is how the flight controller comes in just a little box like this. Here's the flight controller itself here. Very nice and small. Let me get my ruler out here. It is 27 millimeters by about 20 millimeters wide, and then depth is going to be, this is just a cute little 3D printed case for it that comes included, and then the depth with the case here is about, I would say about 7 millimeters there, if that comes out on camera. About 7 millimeters, I would say, in depth. Maybe 8. Yeah, that's how it comes in just this nice little case here. Close that up and put that to the side. It does not come with an XT60 or wires. How I ordered it, there are a few different options. You can order it just sort of plain. You can also order it with pins. Mine, I have tons and tons of servo pins laying around, so I won't actually order those. I have more than I'll ever need, I think, so I'll refrain from ordering more just to have them sit around. The dog actually likes to chew on them, so the less I have, the better. It comes with this little tiny pigtail here. I'll explain this here in a second, as well as 4 little screws to attach the flight controller. It has 4 little, if you see here, very hard to see, there's 4 little holes, one there, one there, one there, and one there, looks like, yes. So one in roughly each corner, and these 2 are above the servo outputs, and you just use the included screws to attach those in there, and it works just fine. You do have, let me see if I can show this here. It's really small, so it's going to be a little challenging to show on camera. Flip it around. We have the USB-C port attached to the board itself, which is nice. I think I mentioned in the Flick video how some of the older Maytech flight controllers had a micro USB coming right off the board, and those tended to not live super long. This seems a little bit more sturdy with that, but still be cautious. Don't just rip it out of there like an animal. Try to give some support to the board while you're pulling out the USB-C cable. There's the boot button right there, works just fine. And if we can see here, we have S1, 2, 3, 4, 5, 6, and then an S12 port there at the end. Really for me on the Flick, I used S1, 2, 3, 4. Really this has as many as you're going to need, and I can't imagine anything more than you'll need, especially this is aimed at smaller planes. If you're putting this in smaller planes, there's only so many servos you can fit. I mean, even if you had 2 motors, ailerons, even flaps, rudder, you have plenty of servo ports here for as much as you want. You have an S-bus pad, which don't know if I care for that being there. I'd rather have an extra UART, but it's okay. And then here you have 2 4V 4V5 pads, which get power on USB, which is nice. And then you have T1 and T5. T1, you have your receiver port and your GPS port right there that both get powered on the USB port. Someone did ask me, I saw in a comment on a previous video, they asked me about current sensing on this board. This does not come with a current sensor. However, if you wanted to, you could plug in an I2C current sensor. I believe Inav has one. I'll leave a link to it below. And you have the I2C connectors there. You could, if you really wanted to, connect a current sensor to this plane or to this flight controller. For me, personally, I stick these in small planes. I'm just going off of the battery voltage. I'm not super concerned with my current, where it currently is. I just look at the voltage, what is it at, how much do I have left, and go from there. But there is the option, if you did have both of these UARTs for a receiver GPS, as well as the fourth here, or the other UART you could use for an HD video system, you do have the ability to use all 3 of those and have a current sensor if that's what you really wanted to do. For me, the receiver, GPS, and HD video system port is plenty for me. So yeah, that's really the ports. There's not a ton on here. It's pretty straightforward. You'd wire up your motor or motors, as well as whatever servos you need for what you're flying. And then, just receiver, GPS, HD port. So that's pretty much very similar to any other flight controller. Where you start getting to differences is I'm sure you've noticed this port here, this little 2-pin here, and if you put it together, that's where this guy goes here. This is your VBAT into the flight controller. So this is going to be giving power for your, so you have VBAT, so you can sense how much voltage you have overall in the craft, as well as it supplies VBAT on this HD video transmitter plug here. So you will have VBAT on this plug. I think I went over that in the Flick build on why I needed a BEC running 4S, because if you do run 4S or any higher voltages up to 6S, you may need to add a BEC in there just because that feeds out straight VBAT. But yes, so very simply how this would work is you would plug this in here to give your flight controller VBAT. Let's see, plug that in. There we go. It sits in here like this. And this is exactly how I had it wired up in my Flick build. Let's get this BEC out of here. Okay, so here, this is the BEC. It's very nice and small. It's about the same size as the flight controller. I haven't figured out what this notch is here for. as far as I can tell, you can't really stack these, so I don't really know what that is there for. You'd have to stack it sort of like that, so not sure. But anyway, this has the battery in, voltage out, just like that, and then you can select what voltage you want in and out. If you can run your servos off of 6.2 or 7.4 volts, I would usually recommend to run them on the highest voltage possible, but for most just typical cases, you can leave it on 5 volts. So anyway, we have the bat plus and bat out there, so we're going to set this down like this for this example. And here, this is our little pigtail. Again, this doesn't come included, but I'm using this as demonstration purposes. So really, what we would have here is our voltage, our VBAT feeding connected off of this pigtail here. Very similar to how I have it in the Flick. It would be spliced in here where the connection, where the battery is here, where the battery plugs up. And these pads would go straight to the ESC. So then you would have VBAT coming from your battery here into the flight controller. I would have an additional set of wires. So you have 3 voltage wires, 3 sets of wires coming off of your XT60 plugged into your battery. One is going straight to the flight controller with the pigtail that they include. These 2 would be going to the ESC directly. And the other pair would go to VBAT plus and minus here. VBAT here, BAT minus, BAT plus. You'd have that extra set going here. And then the out, you would have wired up to one of the spare 5 volts, 5 volt and ground pads. And that's going to give you power for your servos and whatever else you may decide to power off of your 5 volt line. Let me see if I can get this in the image here with the FlyingRC best I can. So here you can see there's the power cables, and I have the 2 sets coming off of each, which is the exact same setup here. Let's see if I can zoom in, ultra zoom here. So this, you can see I have 2, in addition to the power going to the ESC, I have 2 red wires coming off of here, and they are positioned exactly the way I just said. One of those is going to the back here, and the other is just wired in with that pigtail there, and I just have a nice piece of shrink tube covering all those up where they're spliced together and attached to the XT30. That is really as simple as it gets. There are some, I've seen some concerns on the reliability of these guys, and you know, it's not made by a super well-known brand, but in my opinion, having the Beck separated out like this gives you the opportunity to replace probably one of the more common parts to go out on these flight controllers. This guy is not giving power to anything really. It's passing through the battery voltage, and then you're supplying your own power for the servos through your whatever Beck you decide. And this, if it fails one day, you can take it out, replace it with something that is brand new and is working fine. So now that I've given just an overview on this flight controller, I'm going to quickly go over how to install this, install Inav onto this flight controller. I won't, unfortunately, be too much help on installing ArduPilot. I know some people like ArduPilot, but for me, I've always just sort of stuck with Inav. So I'll go over just that process here soon. If enough people are curious, I may decide to learn ArduPilot, sorry, but we'll see. So let me pull that up here and I'll bring you guys in. All right, so here we're going to take a look at how to install Inav on this FlyingRC F4Wing flight controller. First step is you're going to get the hex file from this kindly shared link in Google Drive. Here is the hex for Inav 8, and this is the hex for Inav 7. So what we will do here is download this link. I'll have the link to this folder in the description as well. So we're going to have that downloaded there, and we're going to switch over to Inav, and we are going to go to Firmware Flasher, And we're gonna plug our flight controller in, holding down that boot button. And we're gonna hit allow. So now we can see we do have this flight controller in DFU mode, which is good. And we are going to select load firmware local. And this is where we select this Inav hex here. And we're gonna hit flash. You don't need to fill out any of the board information. That's all in the hex file. And that should flash Inav to this little flight control. It's pretty simple. There's not a lot of documentation I could find on it, but it's really pretty simple. And it'll go through the whole regular flashing process like it normally does. Just make sure to have this on a little bit of a flatter surface. The USB connection is pretty strong, and so I found that because it's so strong, it'll pull the flight controller around with it. So if you have it not super well secure, the USB cable will just pull it off the table or whatever you might be trying to flash the flight controller on. So just make sure. I'm just holding it down with one finger on the actual processor, and that seemed to do a good job. Okay, pretty quick, so let's hit connect. It's gonna take a second here, and here we go. We're in the regular setup for Inav. We'll go through the regular process and everything, just like a regular flight controller. As long as you have everything wired up properly, there should be no real problems. Okay, so if you have any questions, just let me know in the comment section below. I'll try to get to those. But really straightforward process, and I hope you guys enjoyed the video and get to test out one of these flight controllers. See you in the next one.